Many people know that all the objects around us are made up of tiny particles called atoms. Some of them know that atoms sometimes assemble into groups called molecules. Often, this is where the average person's ideas about the structure at the microscopic level of the world in which we live end. Meanwhile, getting a basic understanding of chemistry, the science that studies the behavior of very small particles of matter, is not much more difficult than learning how to assemble objects from Lego bricks. In order to construct the entire diversity of our world, we need only three components: electrons, protons, and neutrons. The first and main particle of interest to us is the electron. The most important property of an electron is its charge. The charge of an electron means its ability to somehow change the properties of the space surrounding it. This space with changed properties is called the electric field of the charge. The easiest way to explain this ability is by the example of permanent magnets. If we put two magnets side by side, they will either repel or attract each other. What causes magnets to interact with each other at a distance is called a magnetic field. The mutual attraction and repulsion of magnets depends on how they are oriented towards each other. Like poles of magnets repel, and their opposite poles attract. Charged bodies, unlike magnets, do not have poles. Bodies and particles with charges of the same sign repel each other regardless of their mutual orientation. And bodies and particles that have the opposite charge sign attract each other. Therefore, electrons, which are carriers of a negative charge, attract to protons, which are carriers of a positive charge, and at the same time try to stay away from each other. Let's remember this fact, since it is their property that underlies both chemical and electrical phenomena. The negative sign of the charge of an electron is a concept that means that it changes the properties of the space around it in a certain way, opposite to how positively charged particles do. Therefore, if we place two equal-sized but opposite sign charges as close to each other as possible, there will be no electric field around them. The electric fields of these two charges cancel each other out. Despite the difference in the masses of the proton and electron, they have the same charge in magnitude. Only the signs of the charges differ. Now we have to learn another fundamentally important fact: the dependence of the interaction of charged bodies on the distance between them. To do this, we can use a luxmeter, a device that measures the brightness of a light source. An application that can measure the brightness of light can be downloaded to any smartphone. After that, we will need to turn on one light bulb in a darkened room and measure its brightness, for example, at a distance of 2 meters from it. Then we will need to move away from the lamp another 2 meters and again measure its brightness. We have doubled the distance between the lamp and the luxmeter, and it is quite logical to expect that its brightness will also be halved. But in fact, the brightness will decrease by 4 times. If you wish, you can conduct another experiment. Inflate a rubber balloon to half its maximum size. After that, take a small paper square and, applying it to the surface of the balloon, approximately count how many such squares will fit on its surface. Then inflate the balloon completely, and repeat the balloon surface area measurement in the same way. If the diameter of the balloon is exactly doubled, 4 times as many squares will fit on its surface. Now imagine that there was a light bulb in the center of the balloon. Each square on the surface of the fully inflated balloon will receive 4 times less light emitted by the light bulb than each square of the half-inflated balloon. The electric field of charged bodies and particles behaves in exactly the same way. The intensity of their electric field decreases in proportion to the square of the distance to them. That is, an increase in the distance between two charged bodies by 3 times will lead to a weakening of the forces of attraction or repulsion between them 9 times. An increase in the distance by 4 times will weaken the field by 16 times, and so on. This knowledge will allow us to understand how electrons behave in atoms, as well as to understand how atoms combine with other atoms to form molecules. Let's talk about protons. As we have already learned, the proton is about 2,000 times heavier than the electron and has an electric charge equal in size to the charge of the electron, but with a plus sign. Now we can take one proton and one electron and create from them our first kind of atom, or, in other words, create the first chemical element. To do this, we simply launch an electron into orbit around a proton in the same way that satellites are launched into orbit around the Earth. The large mass of the proton allows it to play the role of a central body around which a light electron moves. This type of atom, containing one proton in the nucleus and one electron in orbit, was called hydrogen. Immediately I want to suggest that you pay special attention not to the names of chemical elements, but to the logic of their internal structure. But what prevents an electron from falling onto the surface of a proton? Let's assume that this is prevented by the high speed of rotation of the electron, just as the high speed of the rocket does not allow it to fall to the Earth. The speed of movement of an electron around the nucleus of an atom is about 3 million meters per second. And the diameter of the electron orbit, or, what is the same, the size of the atom, is tens of thousands of times larger than the size of the atomic nucleus. But even with such gigantic distances by the standards of the microcosm and the frantic speed of the electron, the attraction of the electric fields of the proton and electron is able to keep them together. Now let's try to assemble the second kind of atoms, that is, the chemical element number 2. To do this, we need 2 protons for the nucleus of an atom and 2 electrons that will rotate around this nucleus. And here a problem arises. We know that even at distances that are huge by atomic standards, the forces of attraction between a proton and an electron are enough to keep them together. How then can we combine 2 protons into one small nucleus, which have the same positive charge and therefore repel each other? We already know that the force of interaction between charges is inversely proportional to the square of the distance between them. This means that when you try to combine 2 protons into one nucleus, the repulsive force between them will be millions of times stronger than the attractive forces between a proton and an electron in a hydrogen atom. And now we need neutrons. They do not have an electrical charge, but they have the ability to keep protons in the nucleus, preventing them from flying apart. Neutrons are a kind of nuclear glue. Therefore, to assemble the second type of atom, in addition to 2 protons and 2 electrons, we need 2 neutrons. These 2 neutrons, together with 2 protons, form the nucleus of an atom, and we launch 2 electrons into orbit around the nucleus. It is clear that due to the mutual repulsion of electrons, they will stay as far away from each other as possible. The second kind of atoms, or, in other words, the second chemical element, was called helium. Let's pay attention to the fact that due to the presence of neutrons in the nucleus of a helium atom, it is 4 times heavier than a hydrogen atom. A hydrogen nucleus contains only 1 proton, while a helium nucleus contains 2 protons and 2 more neutrons. Let me remind you that the mass of the proton and neutron is approximately the same. The presence of electrons has practically no effect on the mass of atoms, since electrons are very light. In a similar way, we can construct the atoms of all other chemical elements. To assemble each next type of atom, we will need to take 1 more proton each time and add more neutrons so that the atom's nucleus is stable. Also, it is important to launch as many electrons around the nuclei as we have added protons to the nucleus. This will make the atoms electrically neutral. The electric field of the positively charged protons of the atomic nucleus will be compensated by the electric field of the negatively charged electrons. A complete atom is a neutral atom. The chemical elements in the periodic table are arranged in ascending order of the number of protons in the nuclei of the atoms of these elements. Element number 1 contains 1 proton in the nucleus. Element number 2 contains 2 protons in the nucleus, and so on. Therefore, you can easily determine the number of protons in the nucleus of any chemical element. It coincides with its serial number in the table. It is clear that the serial number of a chemical element in the periodic table also coincides with the number of electrons that an atom of this element contains. And the relative atomic mass of any chemical element, which is also listed in the periodic table, is the same as the total number of protons and neutrons. They are called by the common word, nucleons, in its nucleus. Now we have to learn, perhaps the most important thing in chemistry, how atoms combine into molecules. Imagine that we have 2 hydrogen atoms. Each of these atoms is electrically neutral, since the positive charge of the nuclei of both atoms is offset by the negative charge of their electrons. Can you suggest a way to combine these atoms with each other to form a hydrogen molecule? Let's simplify the task. Instead of 2 hydrogen atoms, we will take 2 protons and 1 electron. From these 3 elements it is already possible to assemble a certain structure. We know that the force of interaction between charged bodies is inversely proportional to the square of the distance between them. We also know that the charge of the proton is equal in magnitude to the charge of the electron. Therefore, if we place an electron between 2 protons, the repulsive force of two protons from each other will be 4 times weaker than the force with which they are attracted to the electron if both protons are at equal distances on opposite sides of the electron. Actually, the problem is solved. The thing we have assembled is called the molecular hydrogen ion. It really exists in nature and it is stable, that is, it does not spontaneously break down into its constituent parts. It is clear that an electron cannot rest between protons, it moves quickly, but most of the time it is somewhere between them. Hydrogen atoms combine into a molecule in approximately the same way, with the only difference being that their electrons are alternately between the nuclei of two atoms. It is the electrons that glue the atoms into molecules. Perhaps this level of knowledge is sufficient for a person who is not a specialist in the field of chemistry. If you disagree with this statement, express your opinion in the comments. Thank you for your time.